I received another request for help with exercise 7.4. So here goes. And so our little refresher is trying to solve for the composition at which my binary system exhibits an azeotrope. And so here is our equation of interest. This will become our error function. So we're trying to solve for the composition at which alpha is equal to 1. All right, so our error function is going to be 1 minus this is equal to 0. All right, so we're going to keep iterating on x1 until that evaluates to 0. So we're given the temperature, so I can directly calculate P1 sat and P2 sat via my Antoine equation. And then gamma 1 and gamma 2 are functions of temperature and composition. Although the expressions we're using, you only explicitly see x1. And so in theory then, this is all just a function of x1. All right, and so our goal is to use f0 to iterate on values of x1 until alpha is equal to 1. All right, so we're given our Antoine expression there, and then Van Laar equations down here, okay, with all of our constants and parameters. So now if we go and take a look at their code, okay, so I have a function with no inputs, good. And it looks like the first thing I do is I define my Antoine constants for water and butanol, along with my temperature. Then here's my Van Laar constants there. So then I calculate PSAT1 and PSAT2 via Antoine equation. That's good. And actually I want to pause real quickly because now the first thing that comes to mind is here I have temperature in Kelvin. What are the units of Antoine equation? So if you look back, our Antoine equation gives you pressure in millimeters of mercury, which is fine because it's going to be relative pressure, so it's a ratio of 2p, so the units don't matter there as long as it's absolute, so no gauge pressures. And then T is in degree C. So the first thing I'm going to do is that I'm going to rename this TK, and then I'm going to convert T from Kelvin to C. So T, I'll make TK minus 273.15. Bam. Okay, so I do that. Okay, now first red flag that comes up is here I have Van Laar constants A12 and A21. They're underlined red, which means they're not used. Okay, and so we'll have to see where we calculate gammas if they even have access to A12 and A21. Okay, so that's going to be issue 1. So there's PSAT1 and PSAT2. Good, check. All right, so here I define an anonymous function x1, which will just have as an input little x1. Okay, so this part is good because I want my final error function to just have as an input x1, the variable I want to solve for, because f0 will iterate on values of x1 until my error function returns a value of 0. So then here's my general error function. So with that value of x1, I call x1 error with that value of x1, and then PSAT1 and PSAT2, which are currently defined in my function. Okay, and so this would be, again, question 1. So my error function should have A12 and A21 because for each x value, it'll have to recalculate gamma 1 and gamma 2. Okay, so let's take a look then at my error function. Has an input of x1, PSAT1 and PSAT2, so that's consistent. Okay, my next red flag is that x1 is the variable I'm solving for. Okay, but if I were to hover over x1, it's not used. Okay, so f0, even if this were all correct, right, this isn't going to do anything because as I keep guessing different values of x1, this would always return the same value because x1 is not used at all. Right? So no matter what f0 does in terms of iterating over x1, it doesn't make a lick of a difference, right? Because it's not actually used. Okay, so we'll have to try and figure that guy out. All right, gam1 and gam2, you have f0 calls. All right, so first thing is this, all right, my error function needs to be of type function handle. So the only reason we don't need the at sign up here is because x1, right, it's an anonymous function, which is already of type function handle. Okay. Here, though, gamma 1 error and gamma 2 error are just standalone functions. So even if that was correct, I would need to put an at symbol in there. okay, to make them a type function handle. But then if I look further, gamma 1 here has an input of gamma 1, A12, A21, and X1. Okay, so this is problematic because if I'm trying to use F0 to solve for gamma 1, okay, and again, you really don't even need to do this. You could just analytically solve these equations. But if I was trying to numerically solve for gamma 1, then the only input I want here is gamma 1. Okay, so here you have 3 additional inputs, so those would need to be passed via an anonymous function, and it looks like you have the same thing for gamma 2, and then this one is fine. Okay, so now it's a matter of how do you want to do this? Well, let's stick with F0 for now, and then let's upgrade it so that we solve things numerically as well. Okay, I'm just going to add some semicolons here. Okay, suppress some output. All right, so if I wanted to get this version of the code working, okay, issue 1 here, okay, is looking at gamma 1 error and gamma 2 error. Is these, I need to create an anonymous function so that the only unknown input is going to be gamma 1 and gamma 2. Okay, and so when I create anonymous functions, I like to keep my input variables names the same. And so what I'm going to do is I'm just going to call these gam1, not inf. Let's just call like gam1s and gam2s. Sorry. And then we'll call this gam1s, gam2s. Okay. All right. So what I need to do is I need to create an anonymous function. So I'm going to create a gam1 error reduced. Okay. Now this error function I'm actually going to use, the only input I want it to have is going to be gam1, what I'm trying to solve for. Okay. And so what I'm going to do is with that value of gam1 is I want to call gam1 error with that value of gam1. Okay. So gam1 error has gam1, A12, A21, and X1 all as inputs, right? But what I want to do is I want to reduce it so that gam1 is the only input so that I can use F0 with this error function to solve gam1 so that that error function, or that, so that error function returns a value of 0. I'm going to do the same thing with gam2 error. I'm going to call this gam2 error reduced. Okay, it's going to have a single input gam2. Okay, and just trying to keep track of these. This is why I call these, slightly rename these. Doesn't really matter because this comes later, but I don't know. Rather be safe than sorry sometimes and making sure I don't introduce mistakes. Okay, so now that part is good. Okay, and we're going to have to fix this up again though. So now I have these new anonymous functions that'll just have a single input gam1. So what'll happen then here is this will become gam1 error reduced, gam2 error reduced, check, check. All right, so now I'm using my reduced error functions, which only have gam1 and gam2 as an input, which I can use to solve for gam1 and gam2. Okay, good. Then the only other piece of the puzzle is if I look at the input list here, okay, so X1 I have, that's here, okay, but now I need A12 and A21. So what I'm going to do then, and since I have them defined up here, so I'm just going to add them to the input list of X1 error, right, because they're already defined up here, okay, so when I create this anonymous function, I can readily pass them since they're already defined in that function command window. So now I just add them to the list. This has to match up. Bam. And then they could become inputs for, so now I pass them via my anonymous function. They're received by X1 error. Okay, so now pset1, pset2, A12, A21 are all known parameters that are passed via the anonymous function. So I can use them in here. Then X1, right? X1, F0 is going to keep guessing values of X1 until it finds the value of X1 for which that's 0. Okay, so now I properly reduce my gamma error functions to have just a single input, gam1 and gam2, so then I can solve for them, hopefully, and then plug those into my error function here. All right, so let's give it a try. Okay, so let's try homework 7-4. Okay, so it looks like I still have an error message. What's this? Undefined function ln. Oh, alright, so remember in MATLAB, natural log is log. If you want log base 10, that's log 10. Okay, and let's try again. Okay, new error message. Oh, okay, so now this, I'm guessing, has to deal with my gammas. So I'm wondering if the issue is in my gamma 1 and gamma 2s I'm calculating. Because if somehow my function value at negative 14 is that, okay? So one issue is if I just give an initial guess of gamma of 50, MATLAB's going to keep moving out to the left and right until it finds two values that bracket 0, right? But without setting bounds, gamma can't be negative. Well, can gamma be negative? No. So log gamma could be negative. Your gammas, though, are all going to be greater than 0. So if we wanted to work with this, let's try 1e to the negative 10. Let's just see. But then this would be why maybe we try and analytically solve these. Okay, it works. I get 0.7192. So the issue was trying negative gammas. What value do we have? So I have 7940. Okay, so you have 7192. Let's see. Okay, so I mean, from there it'd be a matter of, say, looking at all the values of your constants. Just looking to make sure there's not any obvious error with my Antoine equation or Van Laar equation. Doesn't necessarily look like it, but I'm not also not doing a super rigorous job checking. Okay, but let's check real quick. So 0.011730. So Antoine Constants for water look good. Okay, let's butanol. So those look fine, right? And temperature was 298, yeah, 25 degrees C. And so Antoine's A minus B divided by T plus C. So that looks good. Looks like A minus B divided by T plus C, that's good. Let's look at Van Laar real quick. Oh, looks like it's in my Van Laar equation, right? Because even just looking here, right, there's a squared term, which we don't have. So A12 divided by 1 plus A12x1 divided by A21 x2. So this whole term has to be squared. So that's that parenthesis. So we square that, and let's just assume for now this is the same. Let's see if that fixes it. 7940. Hey, 7940. That's the correct answer. Okay, so we got it. So the big issue here was picking up on my Van Laar constants were unknown, and so I needed to add those to my error function, because with my error function each iteration I need to solve for gamma 1 and gamma 2. And then you were numerically solving for gamma 1 and gamma 2, which is fine. But if I do that, I need to make sure that those error functions only have a single input, which would be gamma 1 and gamma 2 in each case, what I'm trying to solve for. So I would need to pass those additional parameters via an anonymous function. And then the other issue we ran into then is numerically solving our gamma equation. We had to use brackets because we just used an initial guess. Gamma can't be negative, can't be less than 0, because then that causes numerical issues up here. Okay. Now the other thing, you could have just as well done, which I probably would do in this case, is just like the Antoine equation, right? You analytically solved for the Antoine equation, right? Because all you had to do is raise both sides to power 10. Okay. You just as well could have done the same thing here, right? Instead of setting it up as an error function, gamma 1 would just be equal to the exponential of this, right? And so that's something I personally probably would have just did analytically, right? I could just the exponential of that. That way I wouldn't have to worry about numerically solving in the brackets. But all is good.